shut the gates, forget us now. Tides are changing. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Once we shake the ground, you feel it moving. We
Hello there.
Good evening and welcome everybody. It's Obi-Wan Pez for N-Simplex Pachinko. Hi Zach. So you get in there before even my monitor computer did. We're going to be doing some Euclidea tonight, which is another well, it's a game. But I think this should work. Question mark. Yes. If you go to www.euclidea, euclidea.xyz, should be able to play along at home. I already have this on my phone, so this is a brand new account using N-Simplex. But you would be able to do this using other stuff. Hang on one sec. Anyway. So we should, yeah, you should be able to play this online here. You can also get it at the App Store or Google Play. There are links right at the top that you'll be able to click on. If we do settings, that's just language, reset progress, and help. We are not seeing the whole thing. Hold on one sec. Let's bump this down a bit. Right, we have to reset it from last time. And the number of followers is in the way. Yeah. Shift this all around. It'll be fine. Get that. I'll go move that one over. Okay. So, in the overall goal for Euclidea is to be able to, I'm competing with that, hang on. I turned it up because I wanted to be able to hear the music while we were doing our opening screen, but yes, and a Happy New Year's to you as well. In 7? Nope, you're 7 back. So, in 9 hours. This is essentially Euclid's elements. So we are going through a number, not all of them, but a number of the propositions that are given in Euclid's elements, starting out with the equilateral triangle. It is a tutorial level, so it's not like it's hard or anything. But the idea is that we should be able to do all of the fun things like Proposition 1, create an equilateral triangle. By following, the same basic steps. I listened to the podcast. Oh goodness, not annotated, not brief. An Opinionated History of Mathematics, I believe is the name of the podcast. Opinionated History of Mathematics. Yeah, so his particular shtick, I guess, is we're going to go through all of the history of mathematics, and then he has a particular opinion in terms of what is important, and also like what the apocryphal stories can tell us, including how they're wrong in a lot of cases. So, construct an equilateral triangle with a given side. Construction must be exact. Guessing even very close points does not count as a solution. So, the goal stated here is that we're going to use tools that we have available at our disposal at the bottom here. Those tools, we need to do it in 4 moves or fewer, and then also we need to do one that is Euclidean, which is we're only using the compass and the straight edge tools. When we go through, check just means you did it. L means you met the L goal to do the tools, and E means that you met the Euclidean goal of completing it with only compass and straight edge. In addition, when you go to the help menu, there is also a V star, which is if there is a variant of the particular proposition that we're working on. So, for instance, create an equilateral triangle with a given side. It didn't say where that side or where that triangle has to be constructed, just that it has to be off of this one side. So, as it turns out, there are, in fact, 2 ways to complete this. So, if we highlight by just mousing over, this works as well if you're doing touchpad. So, if you have a tablet or your phone, you touch this and then drag it out to the appropriate distance. If you are just kind of putting it out to here, this is not an exact construction because this point is off in space. You could tell it's not an exact construction because it's red. So even if it looks really, really, really close, and even if you are technically on the correct pixel, the problem with this is that this is not actually the correct direction to measure. And so because you're not measuring it correctly, it's going to dock you, if you will. So here we would be able to create a triangle like this. However, again, as I said, this is not actually an equilateral triangle because these 2 points were not constructed exactly. So if we were to move this around, you could see that it's only pinned down at the top. Right, and we are also changing the corner here, which if we drag this one corner out, you can tell it is not creating an equilateral triangle because it's using, again, this point here and this point here as its like grab points. If, on the other hand, I don't think we can change it now. No, we can't. Right, so we're going to have to go back. And then do it the correct way. So grab on the individual point and mark it.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it.
I got facts over tracks, isn't that spitting slow, spitting fast? I could roast, I could gas, think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Gonna learn the consequence of being incompetent. Mental health is confidence, dreams and some honestness. I'm not here to save the day, that's for you to take away. I could play a million mind games, but instead I say something not illogical, something that is topical. Rub it on and watch it go, make yourself unstoppable. Dreams are irresponsible, but they're always possible. If you just believe, you could be so remarkable.
Thoughts in my head, a collage and they spread. I'll be great one day, going off of my meds. No, I'm not giving up, no, I'm not giving in. I will make it to the top, taking off in the wind. I gotta make it, I'm saving every day to taste it. I'm patient, but my mind, it can hardly take it. I'm chasing a dream that I've had for several ages. A vacant, modern kingdom for the taking.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
Put a point. That's interesting. You know what? Put in the intersection point between the circle and the line. So now it is actually correct. Then go back like that. Put in the other point up there. And then dot dot. Now you don't have to. Yeah, and they give us little pithy quotes. In this case, let no one ignorant of geometry enter here. Allegedly put above Plato's university. Yeah. The school. Now, in theory, we should be able to also create another 60-degree angle using the given side, and that should be just here, but, yeah. Not so much. Alright, let's see if there's another variant by taking a 60-degree angle this way, but I don't think that's going to work either. Goodness. So, yeah, realistically, right, it would be able to say, okay, that's also a 60-degree angle. Or if we went this way and made that line going further, we could also make a 60-degree angle down there with this side as one of its sides, but no. There is also explore mode. allows you to look at the constructions and then say like, okay, how does everything change when I shift around the points that were given? So if you did not do it correctly, you should be able to see some sort of discrepancy between the two modes.
They'll be calling me royalty.
Right, and like I said, if we can, there it is. Right, down as well, not up to the side. Should have remembered. Very silly. Okay, so with that, we don't even need this. We just have that side. Okay. If we go to next, tutorial, intersect tool. We already sort of did this. But if it is hard to hit the required intersection since lines are too close together, and if you're like click dragging, it can also grab onto a different point or no point at all sometimes. So you can use the intersect tool to click on what two things you want to find their intersection points for, and then it'll highlight them for you. So, for instance, I want the intersections of this circle and that circle, so it gives me those two. Every intersection has a story. Construct the perpendicular bisector of the segment. So, in this case, we're looking for the line that goes directly through the center and also is at a right angle compared to the other two. Now, I know how to do this, but just in case anybody doesn't, right, what we're trying to do is essentially, can we create a right triangle? Well, we've created a triangle, given the stuff that we've just been doing, and instead of just going and creating the triangles and then making that right triangle, we could just say, give me the intersection point down here, draw an intersection point, draw to the intersection point up top, and that gives us the perpendicular bisector. Education is what remains after one has forgotten everything, i.e. every fact he learned in school. Albert Einstein. Right, and for this one, we need a perpendicular bisector of the line that was given. The line that was given only has one perpendicular bisector, so we know that that is not going to have a variant. You've discovered perpendicular bisector tool. Let's click sequentially on 2 points to see how it works. Right, so if we take this, we click on that point, we click on that point. This is going to get us, we've just drawn two circles and then put a line between their intersection points. So it does 3 Euclidean moves to create the one tool move of the perpendicular bisector tool. Note that the perpendicular bisector tool costs 3 elementary moves. So not Euclidean, but close enough. Midpoint. Construct the midpoint of the segment, defined by 2 points. Again, we can create a perpendicular bisector. And then we have to create lines that go through. And then we want the midpoint, so click the little circle there to get us the actual midpoint of those 2 points. So what do we do? Again, we create a perpendicular bisector. That's it. If, on the other hand, we want to go back and say, I want you to find me the perpendicular bisector, right? That's going to get us those. And then we have to draw the line that goes from one to the other, and then draw the intersection point. So that gets us our tool points, whatever it's going to be. So you have 2 moves on using tools in order to do this one, or you have 4 elementary moves, which are again just compass and straight edge. Without geometry, life would be pointless. Inscribe a square. Nope. Inscribe a circle in the square. So we need to do what we just learned, which are going to be, if we remember from earlier, we learned how to find midpoints, and we learned how to do perpendicular bisectors. So if we do perpendicular bisectors, like that, then we now have a center, and we have an outer edge to touch, and that's all we need. So 3L is going to get us those. However, we've just done 7E, and we should be able to do it with 5. Can't fit a round peg in a square hole. That's enough. So for this, if we go like this and say this is going to be 1, 2, 3, and then we draw a line from here to here, and here to, to here, right? That's it for 5E. So we're 1 too far. So let's go back a bit. Okay, so we need only one perpendicular bisector. So we can get this one right here and get that center point. That's going to be the outer edge of the circle. In order to get the center of the square, in order to place the center of the circle, we don't need to make another perpendicular bisector over here in order to get where the center of the square is. We already have 2 useful points through which we can draw a line. So take the corners. Could have been the other 2 corners. Could have been... no, I mean, that's it. So get the corners going out to their opposite. Yeah. The 2 corners in either case. Connect those with a line. Now, where it intersected the perpendicular bisector from the side, that's also the center of the square. So start circle there and then go to the edge of the square. And we got our 5E. There is no alternate circle that you can inscribe. It is unique, so we're not going to be able to do much else with that. There is no variant, is really what I was getting at. Sorry. Tutorial Move Tool. Pascal's theorem states that if a hexagon is inscribed in a circle, then 3 points of the intersection 3 points of intersection of its opposite sides lie in a straight line. Use the Move tool to see how the theorem works. Just drag the blue points. So here, we just want to make sure that if we do this, we said that, yeah, the intersection points of yes, thank you. The intersection points of the 3 the lines we make of consecutive, was it? Intersection of its opposite sides. So given this point here, the intersection between this point and the lines that connect it to all of the other, it says opposite. If a hexagon is inscribed in a circle, then 3 points of intersection of its opposite sides. Okay, so we extend the sides beyond the circle. So even though the hexagon is inscribed in the circle, extend it further. Then 3 points of intersection of its opposite sides line a straight line, right? So here we've got 1, 2, 3, 4 opposite sides, and we draw those sides extended out. Right, not this one and not that one technically. So here, this one. Alright, so take side 1, side 2, side 3, and side 4. Doesn't say how, no, okay. It doesn't say how many opposite sides it was, right? We need all 4 of them. And when you take all 4 of your opposite sides and then extend them, that's where we get the 3 points that exist here and here and here. Good times. Inscribe a rhombus in the rectangle so that they share a diagonal. So the rhombus and rectangle have to share that diagonal. And then we're going to get a smaller one beyond that. So if it is a rhombus, right, then we want let's use the standing desk. I'm getting too comfy, I guess. I don't think I got a good nap in earlier. Okay. So we need to take the given rectangle here. We need to be able to come off of here and then find the point such that the distance from this point to that point and that point to the opposite corner are going to be equal to each other. So essentially what we need to do is build an isosceles triangle starting from the diameter. Not diameter. Starting from the diagonal here. Actually, is that the answer? Do we want to know where? Is that it? Okay, so we go from a common intersection point on the perpendicular bisector to each of the corners. So yeah, those are going to be equivalent to each other. So then, is that it here? I'm just drawing that one. Yep. Nice. Without mathematics, there is no art. Look up Pacioli. Okay, so we didn't do L because we used just the elementary stuff. I think most of the time I'm gonna go for elementary first, just because that's like the way my brain works. But I think when we get into the higher levels, I'll start using tools much more first in order to get like a sense of how to do stuff. In addition, as we move on, I want to take notes on this and say, like, you know, these are the strategies that we're using these for, right? Because I think a lot of times I get a little far afield in thinking like something like this, right? I didn't know immediately that we should use a perpendicular bisector to get the off angles. It's been like years since I've done this particular level. Okay, so go back, and we can get a second one by doing exactly the same thing. I kind of wish you could like just fade it into the background, but you do the exact same thing, but now on the opposite side. So we need to do the perpendicular bisector of this side, which goes from here to here, and now we can draw in the opposite one here and here, which gets us all variants. Okay, now that this is nice and busy, we're going to reset and then do this as the tools. Alright, cool. Find the center of a circle. L and E goals are independent of each other. Okay. I believe the perpendicular bisector of any chord will go through the center of the circle. So that means we should need two independent... Yes, okay. If we do it with... So if we go back, give me a point that's on the circle. Nope. Okay. Alright, draw a random chord. Certainly the perpendicular bisector of this goes through like just one of these is 3. Yeah, that's not good. Okay, this is specifically equal chords. So if we go, oops, and draw in that one and that one. Yes. Okay. Then these two circles end up intersecting here. And that looks like it's halfway between that one and that one. And then between here, it's this circle and that circle. Ay. Right, and there are no variants because there is only one center to a circle. Inscribe a square in the circle. One vertex is given. So, given that this vertex is here, right, given that this vertex is here, we can get the diameter, which gets us the opposite side, so that's also going to be there. And then if we do perpendicular bisector, we should just be able to get the other two sides. But that's going to take us 8 to get through. Okay. So we need one fewer thing. So if we go back, so if we do this, right, we already have the center of the circle, so that's not that bad. If we do this, no, we don't need, right, we don't need the center because we already got it. Let's try doing this for tools again. So if we have that, that's 2, and then we just draw all 4. Alright, so that's our 6L. Where there is matter, there is geometry. Kepler. Okay, so we reset, and we have to be able to do this in 7 elementary moves. Which means that we need 3 in order to figure out where the other sides are. No, we need 2 in order to figure out where the other sides are, so that we can do all 4 sides of the so we can do all 4 sides of the square as our last 4 moves. So 2 more moves. Let's see. Can we build a 45, 45, 90 triangle and orient it correctly, such that it, maybe let's build this side and that side. Right, so it's going to be like, it's going to start from there, and we have to figure out some way to get this here. And we only have one move to do it. Is that going to be reasonable? How long is the circle? The circle is the square root of 2 long. Or radius. I don't think that there's any way for us to get the square root of 2 out of this without more moves. Like I said, I need 3 in order to mark those sides. Which is 1 too many. If we draw this, this is 60 degrees. Both of those sides, that's 60 degrees. How do we get to 45? This is not quite correct, but you know what, close enough. About there. So how do we do that? Can't do it using a 30, 60, 90 triangle, so therefore we can't do the other circle from the opposite side. We already knew that, but, you know, worth repeating. Hey Rex. Yep, this is called Euclidea. You can go to euclidea.xyz and specify whatever language. And then this is basically running through Euclid's elements. So, like, you know, what are the propositions that Euclid puts forth in Euclid's elements? And he, you know, the first one is that you can build an equilateral triangle. So, super easy. You got 2 points on a line, draw circles to the opposite one, and now you've got equilateral triangles that you can build both up and down. Yeah. Yep. So this is kind of a reminder of how all of that stuff actually works, and how to use Euclid's elements to construct geometry. They've got it set up in packs of propositions that are grouped by relevancy. So basically there's like a theme to each one. What is the final level, you know, what is the final level for each one that we're doing? Well, it's based on all the previous stuff that we were working on. Usually there is 1 or 2 specific skills that they do in that particular section. So I reset, or well, I use my Simplex account to create a new account on Euclidea. And my OB account is currently using the space on my phone. Well, see, that's the thing, is that if you select only line and compass, that's what you're doing, right? It's straight edge and compass, and that's it. There are other tools which give you the other letters here, the other stars. So the check is just, can you do it? L is, can you use the tools to do it efficiently? And then E is, can you use only elementary moves, i.e. compass and straight edge, in order to do it efficiently? You know, minimum number of moves for both of those. So 6L we were able to do fairly easily, because all we needed to figure out was where the opposite point of this particular, we were just given this point up here. No, that's not it. We were just given this point up here, the black circle, and its center. Based on that, we then said, if we just draw the line and then get the perpendicular bisector that goes across, then it gets us both of these points, which are then going to be the other parts, or the other vertices of the square, and then just connect 1, 2, 3, 4. It does take 4 moves to draw those in, so that means that we needed to do it in 2 tool moves. And now that we have just the E, just the elementary moves, we need to do it in 3. Unless we can figure out some way in which to draw a side of the square while trying to figure out where the vertices are. So that's the other thing, Rex, is that there isn't like an easy and hard mode. It's just, can you find them? So can you find a solution? Can you find the tool solution? And can you find the elementary only solution? So generally speaking, I can knock out like all of these. I mean, I've done it before. It's on my phone, right? I just can't remember how to do some of the easier stuff like this, especially efficiently, right? We know how to use the tools. So if we do, like I did before, if we do perpendicular bisector of the two ends of a diameter, then that gets us 2 more points, which are the ends of another diameter, and it's at right angles to the first one, which we see that right there. Which then means we've now got all 4 points, all 4 vertices of the square. So the next question is, can we do this only with Can we do this with only elementary moves? So here we drew the straight line that goes from the circle point through the center, which now gets us the opposite point over here. Now we know that that is, in fact, the opposite corner to this square. Crossing half circles. So, yeah, right, the correct way to do this is say, well, now we've got now we've got a perpendicular bisector, which is from here to here, which is what we did before with the tool, right? Perpendicular bisector tool said, okay, draw the line, that's 1. Draw the perpendicular bisector, that's 3 more. So we're up to a total of 4 moves. And then we could draw in 1, 2, 3, 4 the sides of the square. which works. But the problem is that that's 8. So we need to lose a move somewhere in here. So, like, clearly we need both of these circles in order to make this work. At least I think we do. So Euclidea puts in the full circle, no matter what you do. Otherwise, definitely, I would just put like little tiny arcs where they need to be. Right. So, like, again, what we'd want to do... Do we even need the line? I mean, yes, we need the line, but... There's nothing else to grab onto except this, and, like, that doesn't help. And then these are all 60-degree angles anyway. Right. So, when it comes to the time that it says, oh, draw, you know, inscribe a hexagon, like, we got that now. We know how to inscribe a hexagon. But the problem is that... Ooh. That's fun. That's the same line. Right, because we need one more would get us 4, 5, 6, 7, 8. So again, we've got the exact same problem now. That this is still going to get us 8. Yeah, 8 moves up top. So we need to figure out how to do this with only 7. We didn't have any other points or anything like that. What's this? Nothing particularly. I don't think that's even... Is it? That's getting us potentially the opposite. Is it? Is it though? Yeah, it's looking good. Staying with us anyway. Okay. What if still did this, which gets us the opposite side there. So that's not going to be it. It's definitely not it. We need these points right here. How do we get those points? Where's this? Is that somewhere interesting? Perpendicular bisector. So that's a tool. The one with the X is intersection. That's actually free. It doesn't cost you anything to do it. So basically, if I want to know, like, where are all of the intersections of this circle and this circle, I could just do that, and it'll give it to me for free. So those points right there are going to be the intersections of that circle. Right, so this is all 60 degrees. We need something that's here. I just don't know where that is. Okay, ads are about to start, so we'll go do that, and I'll be back in just a couple minutes. I think... Is there a dark mode? We'll see you in 3 minutes. Be right back. No dark mode. We have some raspberries that we procured at the store the other day. It's one of the interesting things about produce here. I mean, pretty much everything, I think, tends to go bad faster. But it's way fresher when it gets to you. So, it's an odd dichotomy. I suspect because they use a lot less preservatives than the United States. But also, like, we're in Yorkshire, so that's quite a ways away from most of the shipping areas. Like, Leeds has pretty good cargo coming in on the airport. But a lot of things are still coming in from Manchester and even London, which is a 4-hour passenger train ride. Can be longer for cargo. Tonight we are #not sponsored by Adnams, Southwold, Broadside, a barrage of flavors. Don't know how I feel about that. Adnams was established in 1872. The Battle of Sol Bay was fought off the coast of Southwold in 1672. Brewed to mark its tercentenary in 1972, Broadside's taste has endured for over 50 years. It is a ruby red ale delivering a canon of fruitcake notes and charged with the richness of conserved fruit. Oh no. Oh yeah, that's pretty. Let's see if I can get... Let me get my phone up here and shine the... I think you can probably see it. Yes, very pretty red hue to it. I am also eating raspberries. I have been drinking coffee, so this is doing all sorts of weird stuff to my palate. Alright, so Rex, you figure it out yet? Man, that was your job. Okay. So again, going from here to any of these individual... Well, that's not going to work anyway, but going from here to any of these points is a 60-degree angle, so not particularly helpful. If we draw in this midpoint, that is going to get us... Is that 45? No, oh, no. Right, we need to be on the vertical part here, 90 degrees. So, like, that's not even remotely close. I don't know what angle that would be. So we got like 45 out here, 60 here. It's close to 75. But not particularly helpful. And while we're here, right, let's do a little bit of a workout. My whole, like, chest and arms right in here are all sore from the last 2 days we've been doing push-ups. I knew I'd live to regret it. Hope everybody's having a good New Year's Eve. Up here at the Pez household, we've been, well, we were doing a couple of games before the kids went to bed, and then I started streaming. Spouse has been getting into Orange is the New Black, never saw it originally. Good. And up. Enough there. Ooh. And then up and over. We've got Karate, Tai Chi, and Eskrima. Tai Chi is nice and chill. Yeah, well. Oh no. Oh no. Oh, that's terrible. Come on. Autofocus. Whoa. Nope, 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 nope. Don't. Oh dear. I should be able to see the drums. That makes it way easier. Focus. Why are you doing this? That's not doing it. That looks slightly better. Okay. Alright, for our Tai Chi routine. I unfortunately did not get to the double session that happened yesterday because my spouse had the car and I did not plan ahead and get either a ride or the bus or literally anything. So, it would have been really cool. Apparently there are like other people that I don't know there too, so would have been good to work with other people. Alright, so we start feet together slightly, spread apart. And the way that this works is we, I should probably warm up first. It's fine. I'm not doing anything strenuous with the form. I'll give you all some warm-ups. So we do start in this sort of bear. I need to be more relaxed. And then what we do is we tuck into the hip. So we have these inguinal creases that go on the edge of the groin, which separate the thigh muscle from the abdominal muscles. And so like if you put energy into those, they're not exactly like springs, but they kind of coil in a little bit, and then when you release and pop out of it, it tends to add energy to your stance. So it does really good things for you. So if you could take that to any other martial arts, any other martial artists that are out there, it really does help. I've started doing crazy stuff with my karate because of it. So tuck into the inguinal crease and take a step out, and then both feet come back to the center and point straight ahead. And then from here, our arms come up. We take a deep breath in, push, come back down, and then breathe out. From here, From here, we tuck into the left side, grab what looks like an energy ball with the right hand on top, and then twist our right foot around to be in the front. And then we come forward off of the back foot. At the same time, our left foot is going to move forward and out. And we're going to tuck into the right inguinal crease, come back this way, left hand is going to do what's called a ward off. So basically, like, you're reaching out for somebody else's forearm to kind of contact and then be able to read what they're doing based on their, like, the energy that they're putting into their front forearm, because it's going to be like against yours. In the meantime, the backhand just comes up like this, stays kind of low and back. Almost all the weight is on the front, and right leg is pointing out at about 45 degrees. From here, again, we tuck into the left inguinal crease. We come the other way and do a ward off right, and we point with our hand kind of into forearm to hand area somewhere in there. And then we turn this way, shift our weight, and then come forward on the heel of our foot, which causes us to kind of lean into the movement. If you end up using the balls of your feet, you sink down. This is what we do in my karate, because sinking down actually does add more energy to the movements we do. However, in Tai Chi, we need the forward momentum to actually keep going. So we use our heels, which is really hard for me to switch. All right, we tuck into the right inguinal crease. We come down and point our left hand rather than at the hand or middle of the forearm. We point like down to the elbow. Do what's called a roll back. So we lean back, and basically what somebody's doing is they're putting extra energy into our forearm, and we're just going to let them go past us. So we're going to do a roll back like this. We only get to about here. We bring our left hand around and do a press where we put the heels of our palms together and then step into it. You keep your hands, roughly speaking, in the same place. You don't want to like shove or anything like that. You just want to basically use your body weight and the momentum you're putting into it to let all of that do the work. This is a great martial art for older people because it uses a lot of body energy that you just use on a daily basis for moving anyway. So it doesn't take a huge amount of like brand new training. It takes a lot more training, or rather, it takes a lot more effort to untrain habits that you have from other martial arts. All right, and we lean back, arms come on, our hands come apart, and then we, that should be closer. And then we do a push wherein we just, again, walk your elbows essentially where they are in your body and just lean forward. And that is a very effective push technique. Again, you don't push with your hands, you push with your torso. You're basically just leaning into whatever's here. From here, we let the arms relax. We twist in with the ball of our right foot and bring our hands this way. So now we're standing in this very awkward sort of pigeon-toed thing where our front leg is still pointed 45 degrees that way, and our back leg is pointed basically straight forward. So I'm pointing my legs like that. So very, very awkward. So hands come around like this with our front leg into this position. And then what we do is we come around. Our right hand makes a, like basically bird beak. Left hand cups under, set it down. And then we come through, we make like a circle with this, tuck into the inguinal crease, and then what we're going to do is shift with the back, nope, that's the front foot, shift with our front foot on the ball of our front foot. As this is coming around, we're leaning, putting our energy into the back leg. I got that wrong. We're putting our energy into the back leg, leaning this way so that we can quickly shift our front foot to pointed straight out that way. So we're coming from 45 to the front to like the 180 mark. So we're shifting 135 degrees. At the same time, we're going to do a single whip with this one, which is going to hurt. So if this is coming into a strike, basically we're hitting with the back of the wrist. So this is an extremely effective and painful technique, not so much for the person who's striking. So we do this. From here, we shift our leg and come in like this, and then we're going to do all of these things at once. Arm turns, weight shifts forward, and back leg is turned back to the correct angle. So all that happens all at once. Then from here, basically drop our arms gently. It is a little bit faster, but we drop our arms in and throw them out like this in order to prepare for whatever else is coming at us. So this should be about head level, this should be about elbow level, maybe forearm. There is no weight on my front foot except like just to stabilize myself. I should be, back leg should be pointed straight out that way, and then our hands are just in this like relaxed ready position. And then from here, this comes down to block anything that might be coming in at midsection or lower. We shift forward with our weight, and then this ends up, no, that should be here. And then this strikes with the elbow, or no, with the shoulder. So our shoulder comes in, it's going to hit anything that's here, and then our front hand is also going to give a little bit of a tap. Just in case. Let me tell you, it's a brutal move. So start from here. I'm going to do it a little bit quicker. So tuck in, shift. Okay, come here. Come that way. Right, and that is as far as I have learned in the in the form. I asked my instructor, and he said, yes, there is only one form, and it is extremely long. So unlike karate, where there's like a form for every single belt level, and in fact usually two, I guess technically we do like one form per belt level, but most of the time the adults will skip one and learn two forms at a time. Most of the kids will learn two forms at a time if they're good, and learn one form at a time as like default. You know, kids don't quite have the discipline and usually don't practice at home, so they usually get the mid belts as well as the like major belts that the adults do. But Tai Chi also has no belts. Pretty much everybody who comes there is a black belt in something else. Highly recommend, by the way. Alright, a couple of other things. We had practiced, if you put your hand facing down in the back and up in the front. In the front, it's about halfway along the body. What we do is we can keep this up around our face level, and then when we step out, we're going to go into a like horse stance. So this is going to come out like this. It's a squat, and then we throw this thing down at our midsection so that it's essentially resting like just above our thighs, and then snap up, snap down, snap up, snap down, snap up, snap down, snap up, snap down. This is a decent warm-up. This is also a really crappy like $10 foam-covered plastic piece of nonsense. Do not recommend. 0 out of 10. If you end up actually doing like staff arts or any of the like Tai Chi and stuff, I do recommend getting an actual wooden stick, because it is amazing. Just the difference between the thing that I'm doing with this, it's pretty good cardio, and when I go to Tai Chi class, and he has a pole that's made of bamboo rattan, which awesome, and he has a pole that's made of some special wood from China that I don't remember what it is, but and it works really well. The other warm-up that we do, obviously if you're going to do this, you want to also do it on the other side, like just to keep everything kind of equaled out. So you're throwing this down, throwing it up, and throwing it down, and putting the extra energy into the staff is actually causing it to do the wobble. And if you do that both up and down with an actual wooden pole, you know you're doing pretty well. The other thing to do is, let's see, I think it's the same, but this time what we're doing is we're stepping out and doing a spear attack, and then we bring it here. Just to freak you out. But the thing is that if you get it right, if you've done your attack correctly, it should actually also put energy into the stick and cause it to wobble. I've only done it a few times. And again, do both sides. Helps keep everything balanced. The other thing that I could use, and I don't because it's too nice, is a pool cue, because my goodness, is this incredibly weighted, especially toward the back. Right, so in theory, we could also do this with a pool cue, treat it as a staff weapon, because it is. So if we were to do this, right, again, this is too nice of a thing to actually do this with. This was a present from my brother-in-law when he decided that he was giving up pool in order to help him give up drinking. Not a bad combination. Anyway, that was a bit of a long one, but you know, doing martial arts is something fun, keeps you active, and especially once you hit like 30, 40, you need to find a good activity. You need to find something that's going to keep you going and keep you coming back. It's as much social at that age, at this age. That's the other thing, right? I should make like 3 separate redeem categories, or I think I want like a redeem category for martial arts, and then somebody could pick within that category which one they want without needing to either. I mean, asking is fine. But some people just might not have any idea. They might be like, I don't know. Just do karate because that's the one I've heard of. Or Eskrima sounds fun. I don't know what that is. Alright. Zach, we need help on this one, so... Nobody look anything up, specifically. Right? Euclidea.xyz, if anybody's interested in the game itself. I've attached my Google account to it in 2 different instances. So the one on my phone is my Obi account, and the one here is the Simplex account. Right, so once again, here's where we got. If we draw this across, this allows us to then make the perpendicular bisector going from here to here. Great, wonderful, all good. That gets us these 2 points, which, right, because of those 2 points, now we can say, oh look, there's the square. But we've already used up 4 elementary moves, which means that we need to draw the other 4 sides of the 4 sides of the square using 4 moves, which puts us to 8E. We can only use 7E according to our par over here on the side. So because we have only 7E, we need to figure out how to reincorporate one of these moves and say, like, we don't need to do that. But I can't figure it out. And it's been years since I did this originally, so like... But generally speaking, the thing that we need to do, whatever that might be, right? The thing that we need to do to calculate it is probably something that... We don't need the circle in the... Right, so the circle in the middle is given. So that doesn't cost us anything. We're given the circle, the point up top, and its center. So if I reset it, right, this is what we got. So this is what's given. That top point needs to be a vertex of the square. Naturally, this is now unique. So it is uniquely defined based on that one point. Another circle with equal radius, like that. So these get us to, these get us to 60 degrees around the circle. And putting another one in puts us to 120 around the circle down here. Now we did notice that if we did this again, we could actually do the exact same thing here and get those 4 points again, because now we've got the point at the bottom, the 2 on the sides, and the 1 on top. But again, we're at 4e before we draw in the square. And all of these circles were all defined on each other, eventually going back to the point at the top. Right? So without all of those points, we're not able to make the square. Yet. We know that there is a way, because it's 7e. Right? Got just under 20 minutes for New Year's here in GMT, UTC, whatever you want to call it. Right, so doesn't really seem to matter what we do at the moment. The 6L, again, for anybody who wasn't here, is using tools that we have. So currently, all we have is straight edge, compass, and midpoint. Find the perpendicular bisector. So with those 3 tools, we've done this in 6 moves. It'll take more than 7 to do it the way that did it. So if we just use the tools, we can do it in 6. But if we use the elementary moves to do the exact same thing as what the tools do, it ends up being like 10 or 8 or 9 or something. Right, tools are nice and easy because all we have to do is put in this line and then find the perpendicular bisector between those two, and now we have all 4 corners, all 4 cardinal directions on this circle, given that up is north. Right, and then here, because it's 2L, we now have 4 straight lines that we can draw in, which makes 6L. Unfortunately, it is also 4E again, so it makes 8E, which is slightly aggravating, but it's alright. So, again, I've done this on my phone. I know it is perfectly possible. I don't want to look. I don't want to go running to Wiki somewhere and be like, help. I want to figure this out with us. Right here, right now, all that good stuff. Right, if we do this, if it is to connect with this point and that point, that is a 60-degree angle, so we'd be back there again. Which would be great, actually, because if we could move this to that 60-degree angle mark there, and it were okay, then we'd be able to find here these points again instantaneously. So then we'd have this, we'd have this, we'd have this, and we'd have this. Now, the problem with this is it is not exactly correct. Right? If we were to shift this point here, it moves away from the red point, which is not tied to anything, and therefore our quadrilateral is no longer a square. It looked like a square when it was here, but there was no actual guarantee. I suspect it actually isn't, but you know, it's just close. So if we just grab a random point. Right, this does not help at all. So the opposite side would be about here. But I mean, we'd have to know exactly where that point is in the first place, so that's not happening. All right, or if we did the same with like the bottom, no. Right, we need the point that is square root of 2 away so that it hits here and here. Exactly. But I don't know how to make a chord exactly the same as the radius. That's not the radius. I don't know how to make the chord exactly the same as another chord to a movable point. If we grab from here to here, this does get us the opposite point again, but now we're out of moves. We would have to draw the rectangle, or draw the square in. Oh no, we have one more move. Okay, hang on. We have one more move. Not that. So that goes through that point and that point, but it doesn't yield us the other things. Nope. Here to here, that's the same point. Don't do that. This is not going to get us, this is going to get us 120 degrees. With another 60 down there. We need like that point here to draw the line across. So that's not helping. That's actually a good point though. We have not tried that yet. We have not tried this point to the center to see if there's another way to get in this point here. We need to do it in one move. That's 60s. Right. I need something in here. It's not helpful. Is there a way to end up? Is there a way to end up with that angle? We've done this before. Accidentally, but nonetheless, we did it before. It's about 30 degrees. So can we end up with a 30-degree angle? It's half that. Don't do that. Again, we need to be able to draw now. That's tangent, so that's not happening. Alright, that's the center, so this diameter would get us a 60-degree angle down on the bottom here. This gets us a 60-degree angle here. Again, we need another 30-degree angle. Right, we need a 30-degree angle added on to the 60 that's already here. Alright, there's nothing useful for this one. Alright, this intersection's not gonna help. Nor to that intersection. What other intersections do we have? Get that one that's already there. Get that one, that one that's already there. That one, which doesn't really add anything. Again, yeah, we'd have to start drawing the square in now, so that this is not going to help. This is the only circle that we could draw in that's going to be seemingly of any use.
Took a swing at a wrecking ball and I prayed for my
Okay, that's sort of new. We didn't have a tangent before, but we were able to find that. That's 120 degrees. So, interesting, but not helpful. And again, we have to have our, that is our third move, so we'd have to have it done by now. Okay, that's both of those points. It adds nothing new. That doesn't add anything new, although that's pretty close, must say. That's 120 degrees again, but intersected rather than tangent. And down here, that's, again, that's close. It's not 90 degrees, but it's like 105 or something. I almost want to plug that into GeoGebra, just be like, what is this angle? From here, we get both of those points. It adds in 120 degrees again. That gets us the bottom. That's 180 degrees from the original. That's 120 degrees. Well, we're getting a lot of that stuff, but nothing really particularly useful. No, hang on. If we leave this in, that's 120 degrees again. It's not bad. Not gonna give us anything interesting.
Always say goodbye, refuse to question why. I'm just sad to say I'm sorry, so lie.
Alright.
And pretend that you
Out for
don't
ads,
care.
so
Swear that you will stay.
thanks so much everybody for coming on in, and we'll be back in 3 minutes. Just gonna grab a... take the dishes downstairs. See you in a bit.
Sick of all these lies. Don't care if I capsize. Oh no.
Yeah, we're not getting anything good here. Again, the only thing that's actually going to work is if we have these in, which, again, puts us at 4e, which means that we're going to need 8 to make the actual square. Alright, we need some kind of circle is going to get us very different values. We need it to be like I said, we need it to be like here. We need it to intersect here. That is a bonkers location to try to get figured out, right? Because if it's here, that angle is like 105 degrees. If it is here, like here, then that length is the square root of 2. Or square root of 2 times the radius. So, that's not happening. Hey, Happy New Year! Yes, 2 minutes ago. Like, literally the second I came back, I'm pretty sure it actually flipped. So, happy GMT New Year, everybody. Hope this one, happy UTC New Year. Hope this year is better than the last one because, wow. I can't do it. We'll throw those in. Okay. So one more time. What do we need? Okay, one sec. Kids both needed the bathroom, so figured I might as well say Happy New Year. Okay. Ooh. Bubble. Okay. So, we are going to need, that's not going to happen, right? None of these are going to be useful in any way, shape, or form. Unless we can draw tangents, which we cannot. Whee! Right, none of these are going to be helpful in any way, shape, or form. Oh, so we want that to go through there. It's got multiple points of intersection, but it's really nasty. It doesn't go through the center. This one doesn't go through anything. Right, if we want this to go through, then there's a lot of stuff we need to know. Like, how exactly did that happen? My goodness. No wonder the kids woke up. The issue here is that's not tied to the other one. It's not gonna cooperate. It's not opposite. It's not 90 degrees away. When we get close, it just ends up being like the other 60-degree angles. Aye. Random. Can we accidentally use a radius of square root 2? I mean, sure. You can use any radius you want, but that's not really the point, now is it? The issue is what happens when we move. Right, so if you want a radius that is the square root of 2, then we need a right triangle, which is then going to be 1 and 1 on its lengths. Right? That's going to put its vertex like in the middle of the triangle. If that's what you mean, that this was supposed to be the hypotenuse. On the other hand, if we make the entire diameter the square root of 2, right, then that means that there is one and only one location where we can get a right triangle. Let me take that back. At every point along the entire semicircle, we can create a right triangle that connects the upper point to the side to the lower point. But only one of them is going to be your 1 by 1 with the center in the other circle. Okay. button on the app version where if you click on it and you go in, you can actually end up asking for a hint. So they'll say like, okay, what do you want for a hint? Do you want to know the L? Do you want to know the E? Or do you want to know the V? And then you can only do it once every hour, I think, for free. If you want to pay for it, then you are welcome to pay for it, and it'll give you all the hints all the time. I've never paid for this game in my life. I would, honestly. It's a good game. Okay, so if we go to beta, which is also a thing, right? After unlocking a certain number of stars, you can then move on to the next level. Beta starts out with bisecting an angle. No. Don't freaking ask Jonah. Alright, so if we make a circle, this is going to give us 2 points which are equidistant from the vertex of the angle. And then if we go like this, and ask us to give us the perpendicular bisector of the line that goes between them, right? It's the perpendicular bisector of that angle, right? Or that line right there. But we don't actually need that one. We can just say, give me the line that goes from here to there. A. Isaac Newton. The description of right lines and circles upon which geometry is founded belongs to mechanics. Geometry does not teach us to draw these lines, but requires them to be drawn. And again, there is no other angle bisector. This is uniquely defined, so there is no variant. So we can pass on variants. Tutorial for angle bisector. So we now have a tool. Click one point, the vertex, and then another point, and it will give you the bisector of that angle. It does not have to be the angle that you think you're doing. So do be careful. Note that angle bisector tool costs 4 elementary moves. Euclidean manual. Again, circle out, 2 circles back, line drawn. Perpendicular bisector. Alright, moving on. Intersection of angle bisectors. Construct the point where the angle bisectors of the triangle are intersected. So for this one, for the tool, this is easy enough. We just have to draw multiple angle bisectors. And wherever they meet, that's going to be the center of the triangle based on the angle bisectors. Keep in mind, right, the center of the triangle can be measured in like 10 different ways. So make sure you know which one you want. Have the courage to use your own reason. Immanuel Kant. Right, again, this is uniquely defined. There is only one center of the triangle based on angle bisectors, so we don't have to do anything with that. We do need to reset and say we need to do it in 6 elementary moves. So if we do something like this, okay, so suppose that these are the distances out, which means that the circles back, right, are going to be these two. Hang on. I lost. I already got myself lost. Alright, so this is the circle out. And then the circle back needs to be these two. that one was already there. Right? Then this angle bisector can be here. And now we've only done 4, which means we need one more circle. So this circle goes out, hits this one. This circle is coming back, as well as this one. And then we need to draw the line between, was it the intersection point of those two circles, which is down there, there to there, which then we got 6, put the point. Yeesh. Again, uniquely defined, no variance. Draw an angle of 30 degrees with a given side. So we could use angle bisectors. Easy enough. Because if we just draw a couple of circles, we now have a 60-degree angle. Shit. Nope. Okay. Let's do tool. Right? We get this. The bisector between here and here and here is going to give us a 30-degree angle. We can then also do a variant by going down instead. Inspiration is needed in geometry just as much as in poetry. Alexander Pushkin. Okay, so we can also do the same here to here to here. So, variants. All variants are now checked off. Now we need to reset and do this by E. So, elementary moves. The hell, man? Hang on. Oh, okay. I got it. Back it up. Take any random point, draw it to the end point. That's step 1. Then, what we want to do is draw the angle that goes from here to there, because here's the thing, right? When we draw our 60-degree angle, when we do our 30, 60, 90-degree angles, right? Let's just real quick draw this in. Okay. This makes a 30, 60, 90 triangle because here, this distance, or sorry, this angle here is going to be a 90-degree angle, right? It has 2 points which are on the diameter of a circle, which then go up to a point somewhere on the outside of the circle, which makes a 90-degree angle. Then, the side that is opposite the 90-degree angle is our hypotenuse, which has a value of 2, right? So call it 2, whatever it is. Then the short side is going to have a distance of 1 compared to the other, and opposite the short side is the 30-degree angle. Yeah, that took me a minute, but it's not too bad. Right, flip the 30, 60, 90 triangle. Keep in mind, right, I've taught trig for 15 years, so, like, of course I should know this. Okay, let's go to beta. What do we have? Double angle, right? So here, given an angle, make a copy of it on top of itself. So, for this one, we go out, we make a circle. If we make this go down to the intersection point, then it's an equal distance to go up to the other intersection point, which means we can draw a line from here to the intersection point up above. Circles, right? Okay, so that is a check. It is an L because the tools can't do it any faster. The only tools we have are perpendicular bisector and bisection of angle. Damn it. Bisection of angle. So there's no chance there. So it is equivalent L and E in this case. Contradiction is not a sign of falsity, nor the lack of contradiction a sign of truth. Blaise Pascal. However, this also means that we can double the angle in the other direction. So if we go like that, we can also do it down this way. Woo! Right? If we copy the angle up, we can copy the angle down. Easy enough. Cut rectangle. Construct a line through the given point that cuts the rectangle into two parts of equal area. Right? So here, this is what I'm seeing is that we need to cut this into two trapezoids that are just rotated versions of one another. So if we're here, and we want to cut this into like that. I mean, it's not here. It's not here. It is... Oops. Nope. Right, we don't need it here. We need it to be here-ish. Right? Such that this distance here and this distance here are equal to each other. Then, right, let's just think about this for a sec. What do we need to be the same? How can we end up with the same things? Are those equal? That's an interesting question. Are we cutting the same distance off of that particular point and it's distance though, so that'd be tricky because we can't quite do that. How do we get that from this point? Do we go to that one? Doesn't seem to be anything there that's particularly helpful. Can't like cut any angles. Oh wait. Oh. Can we bisect this angle? And then inform? No, that's no. Not even remotely close. Can we bisect this angle? No. However, can we bisect this angle? That's closer. So not quite, but we're getting there. Do we bisect this angle? No. We're on the wrong side. this angle. No. Too close. This only takes 3. It's both. It's 3 for both. That probably goes right through that point. Nah, not quite. Nah, not quite. On the center of the rectangle, maybe. Not there. Ooh, interesting. It's probably not that interesting, but those are parallel. It is that one. Okay. Measure twice, cut once. Yeah. Okay. So this means we need 2. Okay. So it's always through the Really? Is that it? That seems boring. Wait. Go forward 2, and then we just draw a line from there to there. That seems boring. Just draw a line through the center of the rectangle, no matter what point you start with. Okay. Next question. Also fun. Where's the other one? Because there is another one. It should be, I think, at a right angle to that. So a perpendicular bisector between here and here, I think, will yield it. No? Oh, through a given point. Yeah, never mind. Has to go through the given point first. Right, because there's an infinite number of points that will... It's literally, yeah, okay. Any point, any line that goes through the center of the rectangle subdivides it into 2, partitions it into 2 equal areas. Of course. So yeah, they're restricting it by saying there's only one point that it has to go through, and therefore it's uniquely defined. So there should not be a variant for that one. Drop a perpendicular from the point to the line. Okay. Draw a circle from that point. And then we need a... and guess where it is, because again, this does not work. However, if we assume that this is a straight angle, ta-da, right, it's 180 degrees, so half of that is going to be 90. Okay, back it up. We need to do this in 3E. So if that's 1, it's 2, and then 3 we need to draw. So that's not going to work. 1, 2, and that's not going to work either. Hang on. God, why are we doing this? Where? We need this point. This is the same problem we ran into before, right? So we need this to be 1 and 1, and that's root 2. We need that exactly correct so that this could be root 2 as well. Yeah, this is wholesome fun right here. And it's good for you because it helps your brain work stuff out. Puzzling in general, right, is just really quality work. I think I'd like to do one of these times. If anybody's up for it, the puzzle boat. Find the perpendicular using 2 circles, then do a parallel. I mean... But we don't have parallel at the moment. And that's already 3. Hang on. So how do we do this? We did, nope. We go some unknown distance. Doesn't matter what it is. Okay. Then, if we go back like this, this is a 3069, or this is a equilateral triangle. So that's not going to really help. If we go like this, then we've just not really done anything, in fact. Because we don't have a given point. Because we don't have a given point out here, we're not going to be able to construct that 30-degree angle. Not that we wanted a 30 in the first place. If we go like this, these are unequal. That doesn't matter, in theory. These are also unequal. Okay, what are we doing? Right, doesn't seem like doing that is going to help at all. So like doing that might work in some way, shape, or form. But then going that way or that way is not helpful. Right? It's gonna be pretty useless. That's gonna be pretty useless. Wait, okay. This is a vertex. Angle bisector. Hurts my feelings. What are you doing? Right? Because if we decrease the value at which these are separated, so instead of 180 degrees, if it is obtuse or acute, doesn't matter, then those big circles start coming together and form overlapping regions. That's why we can draw a line from the overlap to the vertex. There you go. Woo! This is the same problem we had in the other one, in section 1. That's wild. So actually, we might be able to do the exact same thing. Bravo. This is the same as what we already did. So, and we did it in too many moves. I think this is identical to the problem we had in section 1, in alpha. The one thing that we're missing for alpha 7 or 8 or whatever it is, E. Right? Because we had to do create the square inside of this particular, create a square inscribed in this given circle. I think that, again, this is identical because I'm doing the exact same thing. I want to know, how can I get this in 3? How can I get this perpendicular in 3? Because that will help us get the other one as well. If we can figure out this one in 3, then we can do the other one in 3. Oh, bonkers. Where? Come on. Okay. So okay, so we'd have to guarantee that this is on the center line. This point is on the center line of the radius. Ugh. So if we just draw a circle, there's no guarantee that that's on the center line of the radius. Right? Again, it's one of those like, yeah, it sort of looks like it, but that doesn't work that way. Right? That's not. It is quite off. Arg. So like drawing the first circle around this point allows us to get the locations for the 2 other circles to have their radii, right? Its diameter is the radii of the larger circles. So how could we... gonna get salty. Go out this way. No. We go from a random point to this. And from this to... No. So that's still 60 degrees. Yes, I do a bisector. It was 1L. We did that. So we said do the bisector of a straight angle. So pick a point, pick the vertex, pick another point, and it would automatically do the bisector. The problem that I have is that if we do a bisector from the perspective of, okay, 1, draw a circle, 2, draw the circles that go back, 3, draw the line between the intersection point and draw the line between the intersection point and the vertex. Well, the intersection point is the vertex, so we can't draw a line at the moment, unfortunately. We're running into exactly the same problem every single time. Grr. Okay, if we go here, or here, that's not helpful. Here. Wait. Is that 1.4 times the original? So if we create another circle that's that big, but it would have to be centered here, right? No. No. It would have to be centered here. And we copy this circle to this point. Three circles, small one in the middle, then bisect. Okay, so if we use 3 circles, then we're already over the limit, because we need 3E. So grab 2 random points. No, that's not. No. It's really close, but it's not. It's not that. So close. So if we go like this, grab some random point. Go up beyond this. I don't care where it is. Somewhere beyond it. Right? If we go back to here, and again, that's going to make some random angle. That's going to make a 90-degree angle, but it's going to end up bisecting over here. Grr. Like, again, we're just so close in many different directions. So how do we figure this out? We need to get a root 2, or we either need to get a root 2 or we need to get a Like, that point needs to be the bisector. The bisection point. That's also interesting. How is the computer doing the bisection of the straight angle? Is it just like, well, here's a 90-degree angle, ta-da? That's super cheating. Right? It can't do a construction to get the bisector of a straight angle. Right? Because we can't do a construction either. At the moment. I know. There is an actual construction. It only takes 3. But damn it. How? Freaking A. How is this? Urgh. Just out of curiosity. Is my lamp outputting UV? Say. That's gonna cost me. Oh. Styrofoam brick. That's weird. Let's see. Recyclable. Ah, okay. It's 2. These don't appear to be the same thing as what's in there right now. Must be for a different lamp. Yeah, so I haven't figured it out entirely. Either these output some UV, and so they give me like a super vitamin D boost, because I'm just having this thing shining on my face like pretty much every day, or it does not give me vitamin D, but I'm super extroverted, and I just get like mega boosted with energy because you all are here and actually talking with me. So thank you for being here. We are now 10, 11 days beyond the darkest part of the year, where the sun at 54 degrees north only gets, roughly speaking, 10 degrees above the horizon. I posted a picture of our playground last year when I took the kids to the playground because we needed to get out of the house and do something. So I took them to the playground, and literally the sun was at 1 o'clock p.m., 10 degrees above the horizon. I took a picture of that, and I took a picture or a screenshot of my level when I leveled my phone so that it was pointing straight from my eye up to the sun, and took a screenshot of it. And it was 10 degrees. So I was just like, oh. I'm like, that cannot possibly be correct. Let's just look at that again. But yeah, no, it's correct. At 60 degrees north, it's roughly 0. So between the Earth's axial tilt of 23 degrees, our location of 54 degrees north, and the fact that it was like last year 2 days after the solstice that I took the photo. I counted those up and I was like, yep, that pretty much adds to 90 degrees. So those angles add up to a full complement. Yay! Alright, ads are about to start. Let's go for one more 3-minute break and we'll figure out if we can get past this. If not, we'll just skip to the next one, it's fine. And then we'll do another couple of things. So, see you in a few. Thanks so much for coming. Alright. One more hour. Give or take. Alright, I have also, I think, decided what my New Year's resolution is. That's going to be do better with sweets and shit. I actually do like vegetables, you know, some of them anyway. Most of them, honestly. So, I was like tempted by this giant box of Lindt chocolate truffles, the little round bonbons that are there. I've had enough today, so do better with sweets and shit. Decided, let's take some celery, let's take some carrot. Uh-oh. And then, you could ask me, sometime during the year, hey, have you done better with sweets and shit? And I will say, yes or no. Or even just, hey, today, have you done better with sweets and shit? This is going to be perfect. It's going to work great. I can foresee no problems whatsoever. Alright. Those have nothing to do at this point, so it's not helpful. Alright, let's back up. Let's also refresh, because I want to fix that. Come on. You're still working, come on. Come on. Ugh. Okay, well, this is going well. Okay, so Euclidea is really slow at the moment. I don't know why. Let's go. Hey. got the tool for that one. Grr. Alright, well, we'll let that one go for a bit. Tangent circle at a given tangent to a circle at a given point. So this is actually just going to be a perpendicular, right? Because we want, when is it going to be? Okay, so we have to draw the line first, and then we say it's perpendicular to the line at this particular point. If a man's wit be wandering, let him study the mathematics. Francis Bacon. Sir Francis Bacon, thank you. And again, tangent to a circle at a given point is uniquely defined, so we don't have any variance. And this one's going to be the same problem. So we're going to need, like, this line. That line. Or that circle. Whatever. And then, oh, ooh. No, it's not to the, it's not to the midpoint, because then that is going to be off. Yep. Oops. No. Just go away. Right, if we just prove it, right, yeah, that's not going to be particularly useful. Should only take 3. Right, we have the center, and the point that we want to draw the tangent at is on the edge of the given circle. So if we go right, this would be great for drawing the perpendicular at this point, but not so much for the other one over here. Again, same here. Great for drawing the perpendicular here, but not so much here. Okay. So, hang on a sec. What was unnecessary? The big circle's unnecessary. No. Never mind. That one? No. How do we get the big circle? That came from here, and we went to that tertiary intersection. Right. Ugh. So we only have this circle here. We need to know where this 120-degree mark is in order to make that work. So yeah, the... Excuse me. Huh.
It's about who's willing to help you. Who's willing to stay by your side until the bitter end. So ask yourself, who are you really friends with?
Okay. So that's another option. So, oh. So that probably means that from here to there is also... Okay. Okay, so one circle. So we need one circle from the outer point to the inner point. That gives us 1 point to work with. Ugh. And then the second thing we can do is draw this circle in, but then we don't have any other information about where this is, which is why we need the third circle, either the big one here or a smaller one that would be around this point going back to the origin, or back to the tangent point. Right? So here, this is trying to go back to give you a place to do a bisector. And we just don't have anything to grab onto out here to get the bisector, to get the tangent. There's just nothing there.
Ask yourself, who are you really friends with?
Grr. I want to get that one, but draw a circle tangent to the given line. Okay, so draw a perpendicular from here to there, and then draw a circle from here to there. Easy enough. Oh, and it also gives us the E. Intellectual labor in math lessons is the touchstone of thinking. Vasily Sukhominsky. And again, uniquely defined. Inscribe a circle within a rhombus. Given no information. Okay, cool. So we probably need perpendiculars. No. Oh. Midpoint. Those two. Go from... Draw... Okay, have to draw a line from here to there. Draw a circle from that point to there. Nope. Ah, too bad. Now the problem there is that it's the same distance as the diagonal, so that's not going to help. What if we go to the perpendiculars? Just barely off. We're also, no, that's only 4L, so that's not too bad. Whee! Okay, so that's the center. Easy enough. What about a perpendicular that goes through there and there? Hey. Okay, that was actually all of them. Mathematicians' patterns, like the painters or the poets, must be beautiful. The ideas, like the colors or the words, must fit together in a harmonious way. G.H. Hardy. Probably. Godfrey. Is that his name? I don't think I was aware of that. One of the two gentlemen who bought this book. Had a pretty intense stamp, which says Ex Libri, has a picture of an owl, and then underneath it, it has his name, followed by "A book loaned is not lost." and one of the gentlemen who owned this book, probably after him, scratched out "not." So a book loaned is lost. Alright, so again, there is only one possible inscribed circle. So it is unique. And then that moves us on to gamma, chord midpoint. Come on. It's so slow. Alright. I think completing alpha and beta is probably good for today. At least we've completed main quest. We have not done all of the sub. Yeah, we have not completed all of the all of the sub-stars. That's okay. Go like that, and then we say we want the perpendicular to this line at that point. Nope, that is not what I said. Try again. We want the perpendicular at that line to that point. There we go. Hey, Don, and everybody who's coming in from Don's channel. My name is Obi-Wan Pez. This is N-Simplex Pachenko. We are currently working on Euclidea, which is a math game located at Euclidea.xyz. Hey, Fembox. Famished to finish your poster for pre-algebra. Nice. Yeah, I like the Exod tracks. So he does a really good job with his music, and it's all copyright free, so I'm happy with that. It's gonna be your background so you look at it every day. It's a way to go. The study of mathematics, like the Nile, begins in minuteness but ends in magnificence. Charles Colton. Okay, so the goal here, basically this entire thing is Euclid's elements. And we're trying to go through like the major points and discuss what all of these Euclidean constructions can end up being. See ya? No. This is Exod. Oh, you just Exod and Maestro Chives. And Neoni. Neoni. I suspect that Neoni is the vocalist, but I don't actually know. Get back. Come on. This is also my playlist, which I have made public. So feel free, and if you have Amazon Music, check it out. If you don't, then you may have to put up with ads or something else. Or you could just pop that into like YouTube, because they're copyright free, they're available everywhere. So, yep, nice. And then there's the Don Diablo remix. So in Euclidea we have here all of the different constructions more or less in order, or at least in an order that makes sense. And the idea is that we get stars based on how you've completed the level. So you get a check if you just complete it. You get a star with an L if you have done it with the tools in the least number of moves. You get a star with an E if you have only used elementary operations, i.e. you have only used a compass and a straight edge. So in order to inscribe a circle inside of a square, we need to know first the center, and we also need to know where the midpoint is. So if we were to do that, we could go with something like this. 5, huh? Go with something like this. This will get us the midpoint and the center at the same time, and then we go from the center to the midpoint, and voila, there's our inscribed circle. And some of these have a V star, which says that you can be able to do this in some number of different variant ways. So to create a 60-degree angle, we create an equilateral triangle setup, which is from what we did before. And then either we can go up like this to make a 60-degree angle, or we can go down like this to make a 60-degree angle going down. Now, I don't think, right? Yeah, it doesn't include these other things because it's using the given side, which was the black ray, as the ray for the angle, like the base ray for your angle. So you can't go the other way because that's a segment. So we've been going through section alpha, where we are missing only one star. Doing the E star for the inscribed square. So we are given a top and we're given a center, and we need to do it in 7 elementary moves or fewer. In order to do this with 7, we figured out we can do... Alright, sir, in order to do it with 8, we figured out that we can put a line here. We can either... Doesn't actually matter how we do it. Actually, let's back up. We could do it with circles by making these... And we only get 3 moves. So if we can do it in 3, then that means that the other one's going to be able to be figured out. So like, I want this to be able to go to one of these. And like, there's just nothing here. We were able to figure out that if we went like this, and then like that, and then like that, no, where is it? There. This one, I think, makes a tangent. Yep. But it takes 4 moves. And again, if we can whittle that down by 1, but the problem is that when we whittle it down by 1, we lose this point. So, like, there's no way to do it. Or so it seems. If you lose the first one that got us our Venn diagram here, we lose the bottom point, which becomes the center for the secondary, or the tertiary circle here. And then the intersection point between the original circle and our tertiary circle is going to be the center for the quaternary circle. So, again, just... What is this dark magic? You do have me open twice. You just hear echoes in the background. Yeah, happens every time. And again, erecting a perpendicular from a point. So we need to start with this point on this line and then get a perpendicular built off of it. Again, I can do it in 4, but we need to do it in 3. Right? So we do this, build these up, and then we can, like... No, that's not going to work. And then, right, now we could build big ones like this, and now we have that sort of eye shape again. But that involves building the perpendicular this way, which means we have 4 moves. So again, how do we lose one? Is it going to work? Is it going to work this time? Doesn't seem like it. Hang on. Nope, that's not it. Nope, not that one. Don't open that. Alright, triangle by angle and orthocenter. Construct a segment connecting the sides of the triangle to get a triangle whose orthocenter is in the point O. So this is that the altitudes all meet at the orthocenter. So if we do this as give me a perpendicular from this line to this point, from this line to this point, and now draw the line that goes from this point to this point, that gets us our triangle. Again, this is going to be uniquely defined. We can't come up with anything else because those two altitudes that we had only intersect at one point in Euclidean space. A mathematician is a machine for turning coffee into theorems. Alfred Rényi. Right, so how do we do E on that? Okay, so this is going to, we need one circle that is big enough for both of these 4 locations, or for both lines, right? We need to get 2 points per line, and then from there we can find the midpoint of those particular points. Right, which will get us the orthocenter here. Also interesting question, can we double up any of those? No, probably not. Here to, nope. Circle. Here to there. Here to there. Draw a line from here. Curses. Oop, oop, oop. Wait. From here to there. Nope. Wow, okay. Okay, wait. Okay, no, we got 1 point there. Let's back this up a bit. This is to get that point. Okay, that is now a corner of that triangle. To get the other corner of the triangle, we need the altitude created by those two. Go through here and here, which is that. Yep. And we go from here to there, and it does it in 8. That is a mess. Okay, reset. So from here to, let's do like a minimalistic. Like that. Okay, if we do this, this is going to do it, but again, gets us an altitude here, and an altitude here, which then the top of this altitude is going to come up here, and the right of this altitude is going to come down here. And we don't really have any particular easy ways to get those endpoints. Alright, we can do it in 7. I don't want to draw 4 circles unless they're just going to get me, right? If I can draw circles and they just get me the 2 points, then we're done. But that seems like it's not going to happen. We need... Oh, we don't need that circle. No. Like, no, that's not it. Ugh. We need the circle of the same size that's going to come from... Ugh. Yeah, so we need that. Yeah, man. Yeah. Is there a circle that goes through both of those points? I mean, yes, but the question is, what is it? There's a circle that goes through all 3 of these points, but it is huge. I have no idea where that's going to connect. It is not going to be any of those intersection points. Right, just going like that is not going to do it. Yeah, that one's at least close to that one. No. It's really not. It's good for a bisector, but it doesn't really help us with orthocenters. Alright, let's call it a night here and see if we can find somebody else who's doing some math. Astro Canuck is doing New Year's Eve celebration, doing some giveaways and Legos as usual. Let's see, Ricodactylus is doing Stray-inspired thoughts on consciousness, embodiment, and AI. Seems like a good one, although he's been up for 7 hours, so... Danny Anduza's doing paleontologizing New Year's Eve. Third Rock Astronomy is doing some jellyfish nebula. Who's it? Astrophotography. Physics and Depression, doing some OpenStax college physics. Go see Danny and see what Dr. Anduza's up to at paleontologizing. There is a new, the famous dinner inside the iguanodon. Apparently that was a thing. Righto. I will be back possibly tomorrow to finish up 9 Souls, just so we don't lose it completely, or depending on how I'm feeling, we could just wait until Friday to do other stuff. Anyway, hope y'all are having a good week. Happy New Year to everybody, whenever it happens for you. And we'll catch you next time. My name's Obi-Wan Pez. This is Ensign Blake Spachenko. See ya.